Welcome to 8.3 for IM1. This is video 1 of 2, and the idea here is to learn about midpoint and segment bisectors, okay? So let's just begin with a practical example of understanding what the idea of midpoint is. So let's say you've got a wall in your house or your garage or something, and you're trying to hang a TV on that wall, okay? So you're gonna put this TV and you wanna put it in the center of the room. So how do you know exactly where the center is? Well, obviously this is not the center, and obviously this is not the center. So it's somewhere over here. So the idea of midpoint is just trying to figure out the total length and cutting it in half. So the idea is you would measure the whole length of your wall, right? And you would figure out what it is. That would be your total distance. And you would divide that distance by 2, and of course that would give you your midpoint, okay? So it's a pretty simple practical application for the idea of midpoint. You're just figuring out where to hang the TV on the wall, and you would figure that out by taking the total measure and then dividing it by 2. So that's the idea of midpoint. I don't think that's anything new or grand for anybody. So that's pretty much what we're going to cover for box 1. Okay, here is box 2. Let's dive in a little bit more rigorous and understanding about the concept of midpoint here. So for box 2, midpoints, right, literally means a point that's in the middle. So that's not a big surprise. So over here in the black cloud here, the midpoint of a segment is the point that divides, okay, as a point that divides the segment into 2 congruent, there's that word again. Remember, we've talked about that word in the last section, 2 congruent segments. So same size, same shape. So the midpoint of a segment is a point that divides the segment into 2 congruent segments. So for example, over here on this side, let's say I have line segment AB, okay? M is gonna be our midpoint, and the reason I know this is because I have segment markings that tell me that AM is the same as MB. So we say M is the midpoint of line segment AB. That implies that line segment AM is congruent to line segment MB. That implies that line segment AM is equal to line segment MB. And that's our definition, our working definition of a midpoint. All right, so there's everything you need to know for understanding midpoints and for box number 2. Let's talk about segment bisectors now. So as you can imagine, a segment bisector is exactly what it sounds like. So segment, we know, is part of a line, and bisect means to cut in 2. So a sect and then into 2. So Latin roots of cut in 2. So we're taking part of a line and we're cutting it in 2. That's what segment bisectors are. So for our definition here, a rigorous definition, a segment bisector is a point, a ray, a line segment, or a plane. It can be any one of those. Point, ray, line segment, or a plane that intersects the segment at its midpoint. Okay? So the big takeaway here is that you could have points, you could have rays, you could have lines, you could have line segments, or you could have planes. All of these could be considered and used for segment bisectors. So in this example over here, I have segment AB, okay? And M is the midpoint. And I have a line CD that is cutting AB into 2. It's intersecting the segment at a midpoint. So here we go, line CD. Remember, line is one of them, right? Line CD is a segment bisector of segment AB. That implies that AM, which is this distance, is congruent to MB, which is this distance. That then would imply that AM is equal to MB, this distance over here. So that's how we use our definition for a segment bisector. Okay, box number 3 is going to be an example of finding segment lengths. So in a skateboard design, line segment VW bisects XY. So line segment VW, that's this line segment, bisects line segment XY. That's this over here. Okay, so if we know that it bisects it, we are guaranteed that this segment and this segment are congruent, and it happens to bisect it at point T. We also know that XT, grand total XT, is 39.9. So from here all the way down to here is 39.9 centimeters, and it wants us to find the length of XY. So it's asking us to find all of this length from here to here. Well, we can use the segment addition postulate, and we can say that, well, the total distance, XY, is equal to XT plus TY. So the distance XY, the thing I'm looking for, is equal to 39.9, because that was given to me right there, centimeters. And since we know that VW bisects XY at point T, I know that TY is also 39.9 centimeters, because that's the definition of bisect, cuts it into two equal parts. So therefore, XY is equal to 79.8 centimeters. And if you don't know that, you can, of course, use your calculator and bring that in. Just plug it in, 39.9 plus another 39.9. Feel free to use your calculator on that. That's how I got the 79.8. Okay? There's everything you need to know for box number 3. All right, box number 4 is a U-try. I'm going to do the first one for you, and then I'll let you guys do the second one here, okay? It says identify the segment bisector of PQ and then find the distance of PQ. So I'll do number 1 for you. So here's your sentence frame. The segment bisector of PQ is ray MN. So hopefully you can see this, and I'll point it out to you. So here is PQ. If I go all the way, here is line segment PQ. The segment bisector, since I know that these are segment bisector markings, the segment bisector happens to be I'm not sure what that meant. Anyways, so the segment bisector happens to be a ray MN. And so we're looking for the distance of PQ. So since this is a segment bisector, I know that this distance and this distance are going to be the same. So let's go ahead and add those up. So PQ is going to be 1 7/8 plus another 1 7/8. So that's going to be 2 14/8. So if I keep going with that, it's going to be 2 plus 1 6/8. Which is 3 3/4. Now, if you don't know how to do that, you can, of course, just use your calculator. That's totally fine. But that's how you do that one. So I want you guys to try number 2 on your own. The segment bisector of PQ is a what? So what is that segment bisector? Remember, your choices are line, point, plane, ray, line segment. So choose the right one. And then tell me the distance of PQ. Okay, so hopefully you got the right answer. So you should have come up with point M. And you should have come up with 2 2/7 plus another 2 2/7 is a grand total of 4 4/7. That's an acceptable answer. You can leave it just like that if you'd like to. Okay, lastly, box number 5. It says, using algebra with segment lengths. So it says, point M is the midpoint of line segment VW. Find the length of VM. Okay, no problem. So it looks like if M is the midpoint, that means that this segment and this segment are congruent. They have the same length and the same size and the same shape. So therefore, I can say that segment VM is congruent to segment MW. That tells me that VM is equal to MW. That tells me that this is 4x minus 1. That has to equal 3x plus 3. So all we have to do is a little bit of algebra here. So I'm going to subtract 3x from both sides. So 4x minus 3x is x minus 1 is now worth 3. Let me come over here real quick. So if x minus 1 is worth 3, I would add 1 to both sides, and I would see that x is equal to 4. Okay, pretty easy. So therefore, VM would have to be a length of 4. And that's everything you need for 8.3, number 1.